Good evening and welcome back to your favorite channel, BYJU'S Class 9 and 10 Achievers. Good evening, Prashansa, Rashmi, Rafiq, Aditi, Devansh. Welcome, guys. A very warm welcome. Hey, Ankita, Saranya, Ayan the Great. Madiha is here. Vartika is here. Sarthak, Archit, I can see slowly all kids are joining in. Good evening. How are you all doing today? Hi Shreya, Raj, Shainita. Noted, Ankita. Kanika. Good. Shainita is saying very well. Zarina is fine. Vartika is also doing fine. Sarthak is saying great so far. Great. I'm also doing really well. Thank you. Hi. Good evening. I missed you guys too. Yes, it's been long. Good to know that, Hannes. Hey Archit, I'm doing really well. Thank you. Great. Now that you know the characteristics of matter, let's move on, and today let's cover the different states of matter that we see. So there are so many things around us, right, and they're existing in different states. So what are the characteristics of these particular states? That is the agenda for today. That's what we'll cover from this chapter, Matter in Our Surroundings. Excited to learn new things. Great. Yeah, chemistry is all about exploring and learning. Namaste Shivansh. Avanay is super excited for the class and so am I. Correct, Rafiq, bilkul sahi. Sarana is also super excited. Great. Alright, before I begin, fatafat se green signal de do that you can hear me properly, see me properly. This PPT is working fine. You can see the states of matter written over here. Yes? Yes, Zarina, absolutely right. Great, I've started getting green signals. Correct, Sarthak. We'll be discussing about all, don't worry. Loads of thumbs up coming. Tanisha is saying, ma'am, you're perfectly audible, visible. So Tanisha ki baat mante hain and let's get started. Great. Good to know that, guys. Good to see that you people are super excited to learn new stuff in chemistry. But before we dive straight into it, I've got a good news for you. Byjus Scholarship Test. So this is for all the grades starting from 4th to 10th and all the boards as well. Isn't this amazing? Why do you need to appear for this? You can always assess your basic conceptual knowledge and you can see where the gaps are lying, right? In your preparation, if there is any gap, take the test and you will get to know about it. Isn't it nice? Thank you, Arushi. Madhya is super excited for the scholarship test as well. So yes, guys, go ahead, test your conceptual understanding and aptitude. And what is written over there? You can get up to 100% scholarship. What else do we want, right? 100% scholarship. Isn't this amazing? So you can register for free and the test is going to be every Sunday. Correct. Devansh is saying already registered. Great. Good to know that. Dipesh ne bhi register kar liya. For the rest of you, go ahead, register right away. Divyani, amazing. Yes, I'm coming to the homework question. Don't worry about this. No, Roma, we've just started with the class. You are very much... Yes, I can see that. Great. So, coming to the homework question you people really want to discuss, right? First of all, let's see कि किस-किसने homework question किया. You know the drill. I will first be looking for the students who've actually taken out time to post the answer in the comment section. So, we have a long list today. And the best part is this list is increasing as, you know, we are going forward. That's the best thing. So, we have Lakshmi, Arushi, Monalisha, Utkarsh, Gatik, Abhinay, Sunena, Prachi, Tejas, Archit, Himani, Arpan, Zarina, Rashmi, Aditi Datta. I mean, the list is going on. And I'm just halfway through right now. Okay, moving on, we've got Zarina, Rashmi, Aditi Datta, Chitra Muni, Astha, Shreya, Vartika, Tarun, Prabhat, Brajesh, Raj Singh, Saranya, Bhakti, Ghansham, Lakshmi, Venkatraman, Diya, Tanmay, Aditi, Kevin, Tripti. Well done, guys. I mean, this is the best response ever. You people have actually understood the last class and posted all the correct answers. Yes, I can see some of you posting right now as well. That's great. Hey, Abhi, whenever we take a live session, in the comment section of the same link, you have to post the answer. Yes, whatever you think is the answer for the homework question. Yes, Tanisha, I can see you posting the answer. Correct, Shanita, Saranya, Rafiq. You guys are absolutely right. Correct, I can see that. Most of you have marked the correct answer. Great. How to complete homework? There's just one question. If you'll be really attentive in the class, Dipesh, then you will be able to answer it perfectly fine. I'm really sure. So, let's discuss the homework question now, and in case you've not posted the answer, you can post it right away. In case you feel that you've missed to post the answer, so you can always post it right now. I see Anchal has just written the answer. Hannes is also mentioning now. So the question was, why can we smell the aroma of the hot food from a distance? I see one word answer in the chat box right now. All of you are saying because of diffusion. So for this question, all you have to do is imagine your favorite dish, right? Imagine having your favorite meal time, your favorite dish, and you can smell it from afar as well. Why is this happening? As you people are mentioning, it is because of the process of diffusion. Now, we also study that diffusion increases with the increase in temperature. So when we talk about hot food, the temperature is obviously high, so the rate of diffusion is also going to be more. Now, as hot food has more temperature, the aroma gains more kinetic energy, right? And moves larger distances. And there you go, that's your answer. Correct. Yes, Diya, they are. Ayan is saying we'll get distracted after thinking of food. No, you have to link chemistry to your day-to-day life, not get distracted by that. Great. Awesome. So, let's switch to the other screen once and see what we've got today and what are we going to cover. Are you all set to see? What do we have? Let's merge the screen and see what do we have here with us. Can we have the plain background so that it's perfectly visible? And you people have to be really interactive, right? You people have to keep commenting. So, keep the chat box going. Great. Yes, you can see that now. I have a bottle with me over here. Let me just put it here as well. How many of you can see? Okay, you're guessing it's oil in this bottle. Okay, now based on this, first of all tell me, can you figure out the physical state of this bottle? Let's see. I know you know the answer. I want to see who's going to type it first. Who will be the first person to type it? Physical state. Shivansh is the first one. Physical state of the bottle is solid. I see some of you write about liquid. I'll repeat my question. Physical state of the bottle over here. Prashanta says solid for the bottle. Alright. Thumbs up from my end to you. Now tell me, you see something is inside this, right? Something is present. What is the physical state of the substance inside this bottle? Physical state of the substance, now you have to tell me. You're guessing that that's oil. Okay. Liquid. Alright, let me just shake it quickly. Now tell me, do you realize any third state also? Is there anything else in the bottle? Archit says a gas is also present. And then I see loads of you writing about this. Correct. Let's go back and see what is going to be the agenda for today. So let's quickly switch back to the main screen and see what are the contents that we are going to cover. So let's go back, let's switch to the normal screen and let's get started. So today, as you people said, we will be talking about the states of matter, the solid state. You saw the bottle, right? You all guessed it, it's in a solid state. We'll talk more about this state and its characteristic. Then you people are guessing there is oil in it, ma'am. That I'll reveal by the end of the class. Okay, so liquid state and its characteristics, and of course, gaseous state, you people are saying. So you could figure out that gas was also there. And we will be exploring more about gaseous state and its characteristics. So all these things we will be covering today. Are you all ready to know about the different states and the characteristics? Quick thumbs up to let me know that. Great. Awesome. Alright, first let's go back to the kitchen. Let's go back to our kitchen once again. You remember you saw a lot of things over there. You saw that milk was there, juice, sugar, oil, and I don't know what all you spotted. You remember? And all these things are there in your kitchen as well. But today our focus is going to be on certain things. For example, we saw sugar. That's in the solid state. We saw juice, that is in the liquid state. And of course, gas, vapor. I asked you to figure out the difference between gas and vapor. I hope you figured that out, right? So air is all around, that's a mixture of gases. You see vapors also. So these are the three states, major states that we will be covering today. Let's get started. Great, I see you people are posting thumbs up, which means you are all set for this. Awesome. Yes, Zarina, we'll begin with that only. So, why exactly are these states existing? Why there is a solid state, a liquid state and a gaseous state? To answer this, let's go back and recall the characteristics we covered in the last class. The first important characteristics was particles of matter are tiny and they have spaces between them. So they're very small and they have a lot of spaces between them, right? Now next is particles of matter are constantly moving and they attract each other. Now the variation in these properties basically are responsible for the states of matter that we have. It's the variation. Not all the states have the same, similar or uniform characteristics, right? So say suppose we talk about solid state, in that case space is going to be different as compared to liquid or gas, or maybe the movement of particles would be different, force of attraction would be different, everything would be different, right? So based on this, based on these characteristics, based on the variations of these characteristics, we have the three states of matter. Correct, Anshul. We're going to come to that question really soon. Yes, Rashmi. Correct. Yes, you people are guessing it right, which is the best part. So, we have the three states with us. We've got the solid state, liquid state and gaseous, as you people have guessed it. Let's get started with the first one. That is the solid state. And for that, again, I have something for you. Let's see, what do I have here? So let's switch back and see what is there for you again. You will have to tell me in the comment section, right? I'm looking at the comment section. So let's quickly merge the screens and see what's there. We'll take maybe a minute to merge and then you people have to guess that. You people are guessing I'll be showing you a rubber band. I can see some of you writing about that. Okay. Random guess you're doing. Yes, yes, correct. We are just waiting for the screens to merge and then we'll get started. Can we quickly merge the screen? Yeah, it is actually. All right, thank you so much. Now, what's this? What do I have with me? And what's the state of this substance? Let's see. A diary, a book, a diary. Shivansh is saying it's a diary. A book, diary, notepad. Solid, 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 solid. All of you are saying solid. Keep this in mind, okay? If you're saying this is solid, keep this book, diary, notepad in mind. Okay? We're gonna come back to this really soon. Next, what do we have? Let's see. So, we have this book and then we have this with us. We have the keys with us. Yes? You can clearly see the keys. What about this? Solid again. Okay. Now something that you all have. Some material that you all have with you. 516. All right. Yes. Correct. Phone. Again a solid. Yes, you must be watching this video on the phone, right? Let's quickly switch back to the main screen now and understand something about solids. So let's quickly switch back and meanwhile, what I want you to tell me, when I am showing you maybe the notepad, maybe the phone or the keys, in all these three cases, can you comment something on the shape? On the shape of solids. What is your view on the shape of solids? Meanwhile, let's go back to the main screen. Definite shape. Fixed shape. All right. Fixed shape. Definite. Correct. I'm holding the book. You're holding the book. The shape of the book is not going to change, right? What about the volume? Volume is the space occupied, right? We studied about this as well. Can we switch back to the main screen, please? What about the volume? All right, definite again. Are you people sure? Okay. So you people are saying, maybe the shape, maybe the volume. In case of solids, for example, we saw the key, we saw the book, we saw the phone. According to you, solids have definite shape and fixed volume. Yes, so now you can easily cross-check that as well, right? You yourself can check this, whether this is true or not. You have so many solid substances around you, right? You can easily cross-check anything that we are teaching you, anything that you read anywhere in the book. Yeah, so it has fixed shape and fixed volume. Now, talking about compressibility, it's a new term, right? Compressibility. Look at this word press in this and understand this thing. When pressure is applied, as you can see over here, pressure is being applied, right? As the pressure is increasing, what's happening? The volume is decreasing. Now, if the volume is decreasing, if after applying the pressure, volume decreases, we say that such substances have the property of compressibility. They can be easily compressible. So it's the ability or a property of a substance to be reduced in volume when external pressure or force is being applied. Now, you're holding a phone right now. I assume that, right? Try to press it. Are you able to reduce its volume? Is it possible? Now this, whatever properties we'll be studying, it's generally applicable to all the solids, right? We very conveniently in chemistry use this term generally. Yes, Sarvane, I can see a lot of you are saying not possible. Correct. So, when we talk about solids, the compressibility is not there, right? So, is the phone compressible? I see all of you write a big no over there. So, I'll also write a no. It's not compressible. So, solids in general, they are not compressible. They are incompressible. Yes, we've got exceptions. Chemistry is full of exceptions. And I keep telling you, this is what makes chemistry exceptionally interesting. Great. Alright, now whatever properties are there in solids, why are they there at the first place? We need to understand what is leading to these properties. Right. When we talk about solids, the particles have strong interparticle force of attraction. Okay, they have negligible space between them. Force of attraction is so strong, then obviously the spaces would be negligible, right? And of course, they have fixed position of particles. Now, because of the third property that you see over here, fixed position, that's why we say that solids are rigid in nature. Right, rigidity is always linked to the position of particles. In case of solids, this position is fixed, and that is why we say that solids are rigid in nature. Now, I've been constantly saying that we cannot change the shape of solids, and you are saying the same. But what do we see over here? We see a rubber band, and I saw a lot of you were asking about this. Can we consider rubber band to be a solid, or it is to be some other state of matter? What do you think? In case of a rubber band, as you can see over here, the shape is changing. Is it still a solid? What do you think? A quick yes or no, let me see in the comment section how many of you are able to figure out this answer. Is this still a solid? Let's see how many of you are in the yes team, how many of you are in the no team. And let's see which team is going to win then. Yes, Rashmi, a lot of exceptions in chemistry. Yes, Madiha, you're on the right track. I see all of you in the yes team. All of you are saying yes, it is still a solid. Isn't anybody who is saying no? Correct, Kanika, Shivansh, absolutely right. Sadhna has no idea, so let's discuss this for Sadhna. So yes, first of all, you people are absolutely right. Rubber band is still a solid. Now, when some force is being applied, the shape of the rubber band is changing. But it will regain its original shape the moment this force is removed. So only when the force is applied, the shape is changing, right? Once this force, external force is removed, it is coming back to the same shape. It's coming back to the original shape. So in case of solids, if external force or pressure is there, you can change the shape as well. But that doesn't mean that they won't be considered as solids, right? They would still be considered as solids. Correct, yes. Give me loads of smileys because you people guessed the answer absolutely right. Loads and loads of smileys. You people got this one right. Yes, I'll be shooting in between questions every now and then. Anchal is really happy. Great. Sadhna, I hope you got the answer now. So, in case of the solid state, let's put everything in this one slide so that we can recall later. When we talk about the solid state, it has strong interparticle force of attraction, negligible spaces between the particles, and fixed position of these particles. And that is the reason for all the properties that we see. For example, definite shape, right? Fixed volume. You all checked this yourself. I showed you a few substances and you were able to figure out, yes, they have definite shape, they have fixed volume. They were negligible. Compressibility was being shown by them, and of course, they are rigid in nature. Now you know why they are rigid in nature. Yes? Good. Awesome. You've just mastered the main properties of solids. Let's continue. Let's move on. And now let's move to liquid. Again, let's have the activity time. Let's quickly switch the screen and see what do we have this time. Let's switch the screens. And let's figure this out now. We just have to wait for some seconds. Meanwhile, the screen would be switched. You will be able to see the second camera. And then, of course, we'll be able to do that. So let's quickly switch to the next screen. Yes, we are just waiting. Meanwhile, you can make a random guess what's going to come. Okay, some of you are guessing about liquids. Alright, what do you see over here? You see a glass kept over here, right? I'm putting my hand so that it's properly visible to you people. And then, we are back with the same liquid. Yes? Now, I want you to figure out something. I'll do a very basic thing that we do on a daily basis, right? I'm just pouring this in this. That's all I'm doing. but I'm just doing it in front of you. That's the only difference. Okay. Now, let's keep it here only. Let's keep the bottle here itself. It looks slightly interesting right now with the screen, right? All right, now tell me one thing. What I've done is I've transferred the liquid from this to this. What can you comment on the shape of the liquid and the volume? So, first of all, I want you to comment on the shape. Shape of the liquid. Fixed, not fixed? Let's see who's going to be the first one to answer this. Tanisha, well done. She's saying no fixed shape. The shape of the container is what the liquids take. Alright, what about the volume? What do you think about the volume here? I had around 60 ml in the bottle. I've transferred it to the glass. Same, volume is the same, correct. That means whatever was the volume inside this, the same volume has been transferred here. Good. Alright, let's move to the main screen quickly and let's analyze everything about liquids now. Let's go back to the main screen and let's see what are the other properties of liquids. Yes, Dheeraj, bilkul sahi. Volume is fixed. Volume, space occupied, right? Let's quickly go back to the main screen. And I know you people are absolutely on the right track. Correct. Great. Awesome. Now, let's move ahead and talk about the shape and volume as you people have mentioned over here. Now, when we talk about the shape, this is something that you people have observed yourself, right? There was a liquid in the bottle, which you people are guessing oil, which I'll tell you by the end of the class, is this right or not, was transferred to a glass. And what you noticed, that the shape was not the same. It was taking the shape of the glass, but the volume was remaining the same. So fixed volume is there, but no fixed shape. Good, yeah, that is the point. See, all these things are around you with different characteristics, and we never actually gave it a thought, I think. But we already know all this. Yes, Aranya, I agree with you. Yes, Vartika, you're right. Alright, coming to compressibility. Now I know you people know what compressibility is, right? Over here, we have a syringe, and in the syringe we've put the liquid, the same liquid that you saw just right now. It's in the syringe. Okay, now when we're trying to press, clearly the compressibility factor is missing, right? It's very difficult to compress, difficult to reduce the volume in case of a liquid. So, liquids are incompressible. Great! Good to know that you've understood this part. Now again, whatever properties we are discussing over here, it's everything related to what's happening around us, right? We've just picked up, put it over here for you. Now what do you see over here? The moment you see this picture, what comes to your mind? What's the first thing that pops in your mind? What do you see? Let's see if you can actually... Tanisha says fluidity comes to my mind. Liquid, river, dirty water, water, moving, flow, fluid. Great. Yeah, you people are actually judging everything in the right direction. So water is flowing over here, right? Why is it able to flow? What are the properties? What are the specific properties in liquids that's leading to that? But clearly, we know that water is a liquid and it can flow and it's not rigid. The position of the particles are not fixed, right? It's not rigid. Now, for such class of substances which can flow, there's a term which is fluids. So clearly liquids are fluids. They have the tendency to flow. Now, what are the properties which are actually responsible for whatever liquids are displaying? First of all, the interparticle force of attraction is weaker than solids. The force of attraction between the particles is weaker. And then of course the space is going to be more. And no fixed position of particles. That's how they are able to flow. The position is not fixed. You keep a book, it will remain as it is. right? It's not flowing, but if you spill water by mistake, it's going to flow. Why? The position is not fixed in case of liquids. Now, talking about the rate of diffusion. Diffusion is something that we've done in the last class, right? Intermixing of particles on its own. So, now that you've done solids, you've done liquids, you have two cases over here. In case number 1, you see it's a liquid in liquid, ink in water, right? In the second case, you see solid in liquid. So, solid came in a 4 crystal, added to water. This is situation A, this is situation B. Tell me, in which case diffusion is going to be faster? In which case do you think? Anchal is saying A, Sarthak is also saying A. Saranya is saying Q. Q to hai hi nahi. A, B, A. So most of you are landing on the option A. Yes, A is the correct answer. See, in case of liquid and liquid, when we talk about liquids, the force of attraction is not that much. It's weaker as compared to solids, right? Correct. Yes, that is going to happen, Hansika, don't worry. So the force of attraction is weak. The spaces are comparatively more as compared to solids. And solid came in a 4 in water. Of course, the force of attraction is going to be more and the spaces would be less. So it takes more time for diffusion to happen. Though it will happen for sure. Yeah? So the correct answer, as you people said, option A, and you are bilkul correct. Awesome. So, I want to ask you something. Is it just in case of solids or liquids that diffusion is taking place in liquid, or gases can also diffuse? It's okay, Shaurya, you can always go back, watch it again. Is this happening in case of gases also, or just solids and liquids are diffusing in liquids? Good, yes. And to know more about this, download Byjus, the learning app, and you will be amazed to see so many great examples over there to understand the same concept. So, for really innovative examples and for examples that are related to your life, you need to download Byjus, the learning app. Moving on, let's quickly summarize everything we've covered about liquids. Force of attraction, we know it's weaker than solids. Space is going to be more as compared to solids, and of course no fixed position. Now because of this, a lot of properties are there. For example, no fixed shape. You people yourself have noticed this. I am just putting it together, right? Fixed volume, negligible compressibility, so that means it is incompressible, and of course it can flow. So fluidity is there. Great. Awesome. Now let's move on to the third state, which is the gaseous state. Over here we have a balloon with us, right? And air is filled in this balloon. What can you comment on the shape and the volume? Quickly. Yes, Ansika. Just subscribe to the channel and you get updated about everything that's happening. Shivansh is saying that the shape is not fixed, it takes the shape of the container. So this time we have a balloon. Volume is also not fixed, correct. Volume is basically the space occupied, right? So when it's inside the balloon, when the balloon is inflated, there's a certain space. When it comes out, we really cannot comment on the volume as well, right? So yes, you people are right, no fixed shape and no fixed volume in case of gases. Correct, Kanika, Roma, Aditi. Good to know that you people are interacting. Good to know that you people are making this class lively. Absolutely right. You know, these are basic things, but sometimes we take it for granted. Okay, a syringe is over here. Quick question for you. Do you think it's empty or there is anything inside the syringe? A quick yes or a no. According to you, is the syringe empty or not? Let's see. Devansh says, yes, it's empty. Shivansh says, no, it's not. Yes, no, empty. Yes. So for the ones who are saying no, it's not empty, let's talk to the ones who are saying yes. They are saying yes. Okay. Some of you are saying yes, some of you are saying no. I got it. Most of you are saying no, it's not empty. So for the ones who are saying yes, let me tell you why the other class is saying that. Because there is air inside the syringe and air is a mixture of gases, right? So even in an empty room, it's not really empty, right? There is a state of matter present there. Now, when the syringe is being pressed, what do you think? What can you comment on the compressibility of gases? Is it compressible, not compressible? What do you think? Can be compressed, correct. Up to a certain level, gases can also be compressed very easily, as you can see over here. So they are highly compressible, and this property is something that we actually notice on a daily basis. It's a very useful property. All the oxygen cylinders in the hospital, their oxygen gas is in the compressed form, right? So that, in less space, more volume can be put together. We can have more amount of oxygen that can be stored. Then CNG, LPG, everywhere you notice that this is the property of matter that we are actually using. We are actually applying this. So that's why I keep telling you chemistry is very much related to our day-to-day life. Alright, moving on. Another example. So we are inflating this balloon and then suddenly what happens? This balloon is bursting. Okay, what just happened? We're filling in the air, we're inflating the balloon and then suddenly it just bursted. Why did this happen? Shivansh is saying pressure. Excess pressure. Correct, you people are on the right track. Good to know that you're making guesses and that too in the right direction. So, in this case, what's happening? Obviously, we're filling air, right? And the particles of gaseous state, over here as you can see, they hit each other and they also hit the walls of the container. And what's the wall of container over here? The walls is going to be the balloon surface, right? Now, when they hit each other, they hit the walls of the container. That's happening with the force per unit area, which we call as pressure. So, in a way, we can say that gases exert pressure. Now, when this pressure increases beyond a limit, what happens? This happens. It's going to burst open as you can see it over here. I think you must have faced this in your real life also at some point or the other. Correct. Yes, notice this, good. But now you know why this is happening. रफीक ने बिल्कुल नोट करा है, ये रफीक के साथ हुआ है, नंदिनी के साथ भी हुआ है, सरान्या के साथ भी हुआ है, शाइनदा के साथ बहुत बार हुआ है, too many times she is saying. Devan, Sharan. So now you people know why this happened, right? So, my next question to you is, what do you think? Are gases also fluids? We know that, solids are rigid. We know about liquids being fluids, they have fluidity. What about gases? Do gases have this property, exhibit this property of fluidity? And this time I want a unanimous answer in the chat box. Let me see just one word over here. And no exception in the chat box at least. Yes, I see a lot of you writing yes with a lot of confidence, smileys, thumbs up. Yes, definitely. This is what you're writing. Ki ma'am, kya pooch rahe ho? Obviously, yes. And you people are right. So when you talk about gases, yes, they can definitely flow. That's how you're able to smell everything around you, right? So, gases can flow, they are not rigid, and therefore, they can be easily considered as fluids. Gases and liquids are fluids. Yes, Anshul. Thank you for summarizing that. So, the answer to this question is going to be a big yes. So, for gases, basically, what are the properties responsible for the behavior that it shows? First of all, negligible force of attraction between the particles. Negligible. And why negligible? Over here, as you see, the force of attraction is not too much, because of which the spaces are very large between the particles. Particles are really afar. And no fixed position of particles is there. That's how it's flowing, right? As a whole, let's summarize everything about gaseous state and put together at once so that later when you see, you're able to recall, you're able to revise in a perfect manner. So they've got negligible force of attraction, large interparticle space, and of course, the position is not fixed. So the third point is going to be that the position of particle is not fixed. That's how it can flow, right? So properties, no fixed shape, no fixed volume, सबसे ज़्यादा flexible in a way, right? Highly compressible and can flow. So fluidity is also being shown there. Yes? Alright, let's move on. You've understood everything about gaseous state as well. If yes, I have a question for you. So a poll is going to appear. In case you feel that the poll is not there, please post your answer in the chat box over here. Which of the following does not have a fixed shape but has a fixed volume? And your 60 seconds start now. Is it iron nail, rubber ball, orange juice or nitrogen gas? Alright, this is a very interesting question actually. They are asking you which of the following does not have a fixed shape. First of all, get in this habit of writing the answer after only you read the question properly. Don't be in a hurry to read the question. Does not, because if you will miss this does not, the entire concept would be wrong. So yes, that is the keyword over here. Does not have a fixed shape. Iron nail, rubber ball, orange juice, nitrogen gas. Little help over here. Just classify them based on their physical state, right? And you will arrive at the correct answer. Yes, Devanshu, I can see that you're posting the answer. Most of you are going with the same option. The chat box is flooding right now with one single option. That means you've understood the states of matter. You've understood about solid, liquid and gaseous state. Ta-da! Time's up. And I can see most of you have voted for orange juice. Good to know that. Alright, the correct answer is that only. Orange juice, it's a liquid. Rest of the options were either solid or they were gaseous, right? So in case of liquids, we don't have any fixed shape. They take the shape of the container and of course they have fixed volume. So ऐसा नहीं है कि volume change हो जाएगा. If I hold the glass or you hold the glass, it's going to be the same. Correct, Vartika, because orange juice is a liquid. Absolutely right. Well done. You people have understood this. So the correct answer is option C, orange juice. And with this, we've in a way mastered all the three states of matter. So now I again have a homework question for you. The homework question is, a form of matter has no fixed shape but a fixed volume. No fixed shape but volume is fixed. An example of this form of matter is krypton, kerosene, carbon steel or carbon dioxide. And you can post your answer as well as explain the same in the comments section below after the live session. So a lot of you post the answer right now, and when I'm noting down who all actually did the homework, I miss your name because your name gets lost in the chat box. So right after this live session, come back and post your homework answer, the answer to the homework question in the chat box in the comments section below. Yes? Right now you can give me a thumbs up that yes ma'am, we'll appear for this question. We'll come back and we'll write the answer. Then of course I'll see who all actually promised and who all are actually going to do it. Good. I can see some of you are posting thumbs up. So I'm taking it as a promise that you will be appearing. You will be actually attempting this homework question. And with this, we've come to the end of today's live session. But hey, we can always connect on Telegram as well. And you'll get everything over there, right? You'll get the revision questions, homework questions, session notes. So what we are discussing right now, everything is going to go there. Quiz will be there. All important updates. All the old updates will be there. All the new things, everything you'll know about. So the link is there in the description box. Go ahead and connect with us on Telegram as well. And of course, we keep telling you, we've got you covered because we've actually have a lot of things planned for you. So yes, we've got you covered, guys. Nothing to worry about. The new session has just begun and we'll make sure that you pass the exam with flying colors by the end of this session. Yes, so stay connected with us. And talking of acing the exam, we've got BYJU'S classes with 2 teacher advantage. And what are the highlights of this? Well, 24/7 video lesson on the app. 24/7, guys. Personalized learning journey. So everybody's unique, right? Everybody's got their own unique style of learning. That's why the learning journey has to be personalized. And here at Byjus, we provide the same. Dual teacher model is there, and instant doubt clarification. So all these are major things that would be provided to you. And I think based on this, I can easily say that I can see the energy in the chat box. A lot of you are super excited for this. So yes, go ahead. There is a link in the description box. Try this out. I am sure you will like it. Yes? Great. And of course, don't forget to like this video. Quickly like this video and post loads of thumbs up in the comment section to tell me that yes, ma'am, we've liked the video. Because it feels good when you encourage us. So yes, let's wind this session up on a positive note. Let's quickly like this video, subscribe to the channel, and of course, don't forget to hit the bell icon. Great, I can see people are posting thumbs up. Awesome. So now that you know about the different states of matter, look around you, explore more, right? So keep exploring the magic of chemistry, and I'll see you in the next session. Take care, bye-bye.